Hello and welcome to wherever you are joining us from today. Thank you for being with us today for this webinar, which is titled High Voltage. Now, the webinar will be hosted by myself. I am Brian Parker. I'm IPAF's Head of Safety and Technical, as well as Mike Ashton, who is IPAF's International Safety and Technical Advisor. Mike is based in Australia, so we have a bit of a time delay, but thanks to Mike for being up late at night. Now, we have a great lineup of speakers who will be providing some in-depth insight and knowledge about electrocutions and electric shocks when using MEWPs in the powered access industry. And I, for one, I'm really thankful to those who've shared their time today. There are a couple of videos today, which I will go into a little bit more in depth a little bit later on, but I'm sure you'll find them very interesting. I'd also like to take this opportunity to thank our webinar sponsor today, which is Palazzani, who are exclusively sponsoring today's webinar. Okay, just to give a bit of background really our speakers today. So first of all, we have Peter Wellspring. Peter will be talking about how 1B type vehicle MEWPs are used for the installation and maintenance and transmission and distribution towers in Australia. So that maintenance, how they go about installing, some really great insights into that. And then we will have a video from Glen Cook, aka he's known as Cookie, well known in his circle of expertise. But Cookie will be providing information on the importance of planning work if you intend to use a MEWP in the vicinity of power lines, and in-depth details on what we call step and touch potential and what to do in an emergency situation. Peter and Glen Cook, or Cookie incidentally, were part of the working group who helped us produce the safe use of MEWPs in the vicinity of power lines. So due to time differences of where they are based, they're both in Australia, both their presentations have been pre-recorded, and we'll play that video as we go through today. So hopefully you'll see that. The video was done in with Mike Ashton. So Mike had a really great insight into how they carry out their work and some of the risks over there. Now, we've also got Jim Walden today, who is the Director of Product Safety at Skyjack, and he will be discussing the new machinery regulation and how these may affect equipment use and selection in the future. And certainly from his point, hopefully you'll find that very informative. Okay, so we'll start off with a bit of an update from myself, and then we'll also then cover the Q&A session towards the end of the webinar. Now, if you do have any questions today, please do use the Q&A function. You're more than happy to put your questions in there. Please be aware that not all questions can be answered, and also try and keep them specific to the subject that we're covering today. So our targeted safety campaign for 2023 was called High Voltage, and quite simply, we need to do something about the amount of incidents that occur globally with power lines coming into contact with power lines. The campaign now has had over 4,000 views, and the new guidance document has been translated into the IPAF core language. I think something like around about 10 languages. Now, we will monitor this campaign, firstly in the short, but in the medium and in the long term. We want to make sure that, any campaign that we do, put together and run does have an effect globally. And we certainly need to improve this in this matter. We've also created a dedicated safety campaign on our website, and that's got toolbox talks, and safety briefings, or that's maybe what you know, about how we can avoid contact with power lines. We've also created a new short, an IPAF short, which is, how you can, raise awareness of this with your teams and your staff. And I'll just show you this video, 15 seconds. Okay, so 15 seconds is about my attention span. There's probably a lot of you I know on here are probably thinking that as well. But I think these are really great, a way in which we can reach some of our, new people that are into this industry, certainly on the social media and some of the other ways in which we can do that. So I think these are great. There is a series of these now available, so please do go and use these and get them out into your teams. So let's dive into 2022 accident data. Now, if your curiosity does get the better of you, then please do head over to the IPAF website and view the IPAF Global Safety Report for the 10 and the 3-year data. I'm not going to focus on that today. We simply haven't got time. But let's look at the numbers. So the total number of reports was down for 2022, but the countries pretty much remain the same. When I mean countries, I mean that countries who are reporting. So Mexico, America, England, the UK, China. So we do need more countries reporting. So if you do know of any incidents that occur in the countries that you join us with today, please do head over and report this instance. Now, the number of people involved is also down, but this is probably due to the reduction in the reports for that same period. But I suppose in some respects, it's great to see that the number of fatalities is down, and that green number is down on the previous year. So, with some good numbers there. The main point I really want to highlight here is that telecommunications and arborists or arboriculture sectors accounted for a quarter each of all of the incidents. And it's the first time we've kind of seen the telecoms industry rise above the arborists. So it's something that we need to be very much aware of there. Also, you can see in 2022 that 1B vehicle type MEWPs was the most common type of MEWP, for instance, to happen. So, let's just try and remember that. Some data up there about sort of countries that have actually reported incidents to IPAF. But, in terms of 1B, so truck mounts, van mounts, trailer mounts, and spider type, but predominantly most of it would be the vehicle, 1B vehicles, certainly from there. And in the US, of course, there's a huge amount of these types of equipment. Okay, so for 2023, year-to-date reports have increased across essentially all measures, really. But as you can see, naturally, you get more reports, you're going to have more people involved, and sadly, you're going to have more fatalities. We tend to find that people will report the serious ones, but not so much some of the sort of near misses or the incidents that also occurred. And we are still interested in that. So if you do hear of any potential near misses or anything like that, then please do head over to the IPAF portal to report these. So featuring on again, if we just go sort of consistent here, it kind of shows here now. On the previous slide, I showed you for 2022, it was 1B type equipment. Now you can see at the very bottom there that has turned on its head. And so for 2023, this is provisional data at this moment. It's not been finalized, but we're looking at mobile booms being the highest causations or type of equipment that's been involved in this. So you can see that. And also sector-wise, you can see in the past we had arborists and telecommunications, and now we have construction. So remember, this is global data, and that kind of giving you hopefully a bit of an insight there. The image on the left is nothing about where that data is coming from, because we do get countries all over. This is about where our documents, where our guidance, where our targeted safety campaign and information is being accessed. So you can see this is essentially what we use as a heat map to track where most downloads come from there. So please, let's get some more of these colors on the board, and let's see if we can get some more guidance used around the world. So that concludes my very, very short update. We'll now watch a short film from Palazzani. Okay, thank you again to Palazzani. So this video now was conducted by Glen Cook, Cookie, and Mike. Now we strongly, there is a bit of a sort of a warning there, but we strongly recommend that individuals who may find this distressing carefully consider whether they should proceed with watching the next presentation. So discretion is essential, and if you choose to continue, please be aware that some of the content may have an impact on your well-being and emotionally. If during the presentation you find the material overwhelming or distressing, you should continue watching. Remember, of course, your mental and emotional well-being is of utmost importance to us. So I'm just going to watch a short video now.
Just a bit on Cookie's background first for the viewers. He was the Australian Safety Professional of the Year back in 2020 and won an international award for safety in 2022. He was a key member of the working group and played a pivotal part in the development of IPAF's guidance document, the Safe Use of MEWPs, in the Vicinity of Power Lines. Cookie spends most of his time travelling throughout Australia, providing advice, support, and educating anyone who uses equipment in the vicinity of power lines. Over to you, Cookie.
No worries, mate. You can see that now, yep?
Yep.
Cool. Thanks for the intro, mate. Appreciate that. Look, just quickly a little bit about myself too. I never thought that I'd be in safety. I was an electrician for over 30 years. The bulk of my time was on the tools, climbing poles and digging holes and working at elevated work platforms. But I've been involved in numerous fatalities. That's why I'm so passionate about making sure people know how to work safely around power lines. Like the first incident that I went to was a fatality involving an elevated work platform, which is this slide that I brought up now, right? So that elevated work platform was up near these 11,000 volt power lines, and there was a painter with the aluminium paint roller in his hand, and these lines here are 11,000 volt power lines. So like he did not even touch the overhead power line, and the electricity arced or jumped, and he got electrocuted right across the road from a high school, a local high school, in front of about 100 people. So my career path completely changed after this incident, coming into safety and just trying to be an advocate for different industries to make sure that they understand, safe work near power lines. And, this stuff is happening every day, not just in the agricultural sector, but in any construction sector. Like, incidents like this at a rental company in New Zealand a few years back, a young bloke was doing some maintenance on an elevated work platform and, extended the work platform up into the power lines and was electrocuted. This happened in Australia, in Queensland, 6 weeks ago. The exact same thing on a property. They had an elevated work platform, scissor lift, not operating properly. They parked it up underneath the power line on Friday. Monday morning, 22-year-old comes out to do repairs on the elevated work platform, extends it into the overhead power lines. He's now deceased, right? These things are real. They're happening all the time. It's just tremendous releases of energy at one point in time, right? It can do tremendous harm to your body. It can do tremendous harm, obviously electrocute you. This is an incident that happened in the US in February this year when I was over there receiving my international award, right? The reason why it does so much damage to your body is it's 30,000 degrees. When an arc forms, 30,000 degrees, right? In an instant, just a tremendous release of energy at one point in time, right? Electricity can arc or jump, as I mentioned before. I'll just show this one. So this is, shows you how far the electricity can actually arc or jump. The non-electrical people don't realise how far or how close they are to death. People in this industry, if they get too close to a power line, they are dead, devastated, or extremely lucky. They are your three options, right? And it happens so often. Like in Australia, it's 10 times a day. Now, Phil, I'm not sure whether you said that everyone's going to do a test here today, but I want you to just have a look at this video I'm about to play and listen to what I'm asking you to do in this video, and we'll talk about it afterwards.
This is an awareness test. How many passes does the team in white make?
Go!
The correct answer is 13. But did you see the moonwalking bear?
Go!
Look, I use this video just to highlight to people that it's a real human factor that people do not see power lines, right? Myself, working in the electrical industry, I drive around all day and I see power lines everywhere. I always ask people when I do a session like this, I said, when you drove here this morning, how many power lines did you see? And everyone looks at each other going, I didn't see any power lines, right? People absolutely know power lines are there, but they don't see them. It's a human factor. You know, Obi-Wan Kenobi's 100% right. Your eyes can deceive you. Do not trust them, right? So understanding that we have human frailties, and it's a thing called inattentional blindness, all right? It's that one point in time when your brain does not perceive a risk or a danger. So your brain's trying to conserve energy and it can blot out the power lines, or it can put the power lines into the background, telling your body you need to conserve energy. You know the power lines are there. Don't worry about it. But your brain has tricked you that power lines aren't dangerous. And it happens all the time. Like this bloke here, you know, there's a marker every meter on this line and he still managed to hit it. And he absolutely knew it was there. So it's about getting people to understand that they need to properly plan near overhead power lines, right? And putting in good control measures, you know, such as flags, or in my experience, flags only work for the first couple of weeks and then they become the norm and they blend into the background again. So in Australia, we've been using these products called rotor markers, and they're up there spinning on the line and they absolutely catch the movement, and people then see the power lines without just tricking themselves and tricking their brains into seeing them. You don't need one every 5 meters. 1 or 2 markers can absolutely make a difference, right? So this little photo here, there is some power lines in here, right? I'm not sure whether you can see them, but can you see them now? Can you see them now? Right? Once you put a marker on it, particularly a rotor marker, your eyes will join the dots and you will see the wire, and it brings the power line and brings it front of mind. So, it's, like I said, it's getting rid of all those human factors, because we will make mistakes. We learn by making mistakes. And if you hit a power line, it could be the last mistake you make. So you need to have products available that will take the human element out. And there is one product out there too called Go Up Safely, which is the only product in the world that actually stops the machine from operating. It's not just an alarm. It sees the power line and stops the machine from operating any closer to the line. So I really recommend that people look at this product to take out that human factor, all right? So another thing that I always talk about as well is knowledge is the best defense when it comes to electrical safety. So if you hit a power line, understanding what to do in that emergency is really imperative. And the way to understand is understanding how electricity works in its basic form, all right? So here is a 12-volt system. You got a positive terminal on the 12-volt battery of your vehicle, right? Electricity, all it wants to do is complete a circuit. That's its ultimate aim. It wants to get there as quick and as easy as possible. Electricity is extremely lazy as well, right? It'll take the quickest path. Normally that's through metal, right? But if it goes through the human body, that's why we get electrocuted. We're also a good conductor of electricity, right? So if you close the switch, right, or turn the switch on for your lights, it completes the circuit, gets back to its power source. Electricity is extremely happy when it can do this. If it can't, electricity gets really angry, and that's where the arcing and sparking comes into it. All right. So it wants to ramp itself up and jump and complete the circuit. Electricity will also go through the earth to do this as well. So if a power line falls on the ground, electricity flows through the earth like ripples in a pond. So each one of these ripples represents a different voltage. Where the rocks hit, might be 11,000 volts. First ripple, 10, 9, 8, and so on. This is called the surface voltage gradient. That goes through the earth, and you can be electrocuted by just standing near a machine that's hit a power line, or standing near a fallen power line that's been knocked down by a machine, for example. So here's a mobile crane example, right? Mobile crane's 11,000, has hit this 11,000 volt power line. The crane is now part of the power line circuit. It's at 11,000 volts, right? Goes through the machine, starts to hit the ground, and you've got the surface voltage gradient going out. They're the ripples, and they're the different voltages. So if you had 1 foot on the 7,000 volt line and 1 foot on the 8,000 volt line, the human body is a better conductor than the earth. So the electricity will go through the earth, see the human body, and it'll go up through your legs, and you can be electrocuted. It's called step potential, right? So 1,000 volts, so the difference in voltage will go through your body, right? And you're not touching anything, you're just standing on the ground, right? So if you're actually touching it, like this bloke here, the dogger was hanging onto this load, the electricity's gone down through this wire rope, and he's become the switch. So the electricity has gone through his body. That's what's called the touch potential. Now, the touch potential is full voltage. That's where people usually get electrocuted. Now, you could be standing on the ground, touching that load, or you could be in an elevated work platform, for example, like the fatality I spoke about at the start, where the bloke had an aluminium paint roller. He becomes that switch, and you get the full touch potential, right? So, you know, the safest place to be is actually in the vehicle, all right? So if you stay in the vehicle, you're like a bird on a wire, because the electricity will 100% go through the machine first, because metal is a better conductor than the human body. And as I said, electricity is very lazy. It will go through the metal 100% first before it will get through you. So it's really important, and that's why I said before, knowledge is the best defense. Because in an emergency, if you understand that the safest thing to do is to stay, and we say stay, cool, wait. Stay in the vehicle or in the machine and stay 10 meters away, call 000 or emergency number and wait for help. So 000 is our emergency number in Australia. So stay cool, wait is that really important message to make sure that people don't panic, because most people will panic in this situation because they've hit a power line and you go into a fight or flight response and you just want to run. All right, so understanding that, like here's an elevated work platform where a bloke hit a 132,000 volt power line here in Australia. He was not hurt, right? Because all the electricity went through all the metal. That purlin was touching the elevated work platform, so it went through all the metal. He's just like a bird on a wire, right? If he was hanging onto that purlin and then not touching all the metal of the machine, he would have copped the full 132,000 volt power line. Voltage, right? And he would have been electrocuted due to touch potential. But because he wasn't, and it was touching all the metal, it went through all the metal and even blew big holes out of the concrete on the ground. All right. So really important to understand how electricity works and that stay cool, wait message. And we make stickers like this to help people understand that the stay cool, wait message is the most important. And, you know, obviously if you need to escape, you've got the escape procedure there, but as it says over here, absolutely necessary, all right? It's got to be a fire or you're going to die from other means, right? So much smoke or gas and you can't breathe anymore. Otherwise, the safest place to be is on that vehicle or in the vehicle, right? And, you know, you got more chance of winning a large lottery than actually hitting a power line and having to exit the vehicle. So, you know, teaching people the electrical theory, so knowledge is the best defense, stay cool, wait. That's a really important message, all right? Look, I always ask people this question too. What do you reckon gets hit more worldwide, overhead power lines or underground power lines? And I usually trick people because people go, well, if you can't see it, then it must be the underground. It's overhead, right? We hit more overhead power lines, and in particularly in Australia here, we actually see 25-1. Overhead power lines to underground. So it goes back to lack of planning, people not understanding that their brain and their eyes don't work that well together, and inattentional blindness can kick in. So we've actually built an app over here. It's called Look Up and Live that maps all the overhead power lines. All right. So it helps people come up with a plan to actually work near those power lines. You can see here we've got all the power lines mapped in Australia. You know, you open it up on your phone and it tells you the voltage of the power lines, you know, where it's 11,066, and then we have the yellow dotted lines, which is the exclusion zone from above. So it just helps people form a simple plan to make sure that they put good control measures in place, either, you know, removing the power line hazard by talking to the power line owner, turning it off, getting it moved, get it put underground, or rotor markers, or for example, the go up safely product. All right. So really important to just have simple plans in place. And, you know, people hiring machines and stuff like that, it's, you can teach people or educate people as they're leaving or using machinery that, number one, you need to have a plan. If it does go wrong, that you need to have that stay, call, wait message in place, right? So I have done a little video here. I might just add it in on the end. It goes for about 60 seconds. So just as a lighter way to finish this webinar, I've done a parody on Billy Joel's "They Didn't Start the Fire," and it's called "They Didn't See the Wire." So it's just got a little good way to educate people on the power line safety messages. So I'll just end with this one. Oh, if it'll play for me. There we go.
Streetlights, power poles, pillar boxes, name them all. High voltage, low voltage, they them all. Tree loppers, carpenters, truck drivers, farmers, council workers, farm workers, name them all. Spray rigs, tip trucks, forklifts, tractors, high loads, graders, work platforms, bobcats, backhoes, excavators, digging holes, slashes, harvesters, garbage trucks. They didn't see the wire. It was always there, hanging in the air. They didn't see the wire, looking underground, 'cause it wasn't found. Planes, drones, parachutes, don't hear your excuse. Scaffolding, irrigation, augers and cranes, guttering, roofing, cane, harvesting, dozers, ladders, drilling machines. Look up, look down, should've looked all around. Keep your life, happy wife, make it home with your life. They didn't see the wire. It was always there, hanging in the air. They didn't see the wire, looking underground, 'cause it wasn't found.
So yeah, just a simple little video to help people, you know, highlight the power line dangers there. So if you want to find it, it is on YouTube. If you want to share it around with people, just search "Cookie that they didn't see the wire." You can scan that that code there. But look, sorry I couldn't be there in person. It's a little bit late for me here in Australia, and I've got a busy safe work month going on. So I'm hoping that was of value to you guys. And look, I am available to help people, and you know, I'm on LinkedIn and stuff like that. So if anyone out there needs some information or help, I'm more than happy to assist. Anything else from you, Mike?
No, I'd just like to say thanks very much, Cookie. That was a really informative video. And I can honestly say that Billy Joel's got some healthy competition as well. So thank you for your time, mate. Much appreciated.
No worries, Mike. Hope everyone enjoys the webinar. And yeah, catch you again soon.
Thank you.
Okay, thank you to Cookie and to Mike there. That was certainly insightful, and yeah, certainly guy's got a singing career ahead of him, and that was in playing, by the way. So really thanks into that, into the step and the touch potential, and certainly what to do in an emergent situation. So now we're going to move on to another video, this time by Peter Wellspring of Bronto in Australia.
Just a bit on Peter's background. Peter is the technical and training manager for Bronto Skylift, Australia and New Zealand. So Peter has been involved with truck-mounted MEWPs since 1993 as an operator, a trainer, a safety manager and an owner. Peter was a key member of the working group in the development of IPAF's guidance document, The Safe Use of MEWPs in the Vicinity of Power Lines. And in 2018, Peter wrote a code of practice called Truck-Mounted EWP. The purpose of the code of practice was to give practical advice about how to manage risks associated with the truck-mounted platforms in Australia. Okay, so, okay, Peter, we'll jump into the 3 questions. First question for you is, Peter, can you provide a brief explanation on how vehicle-mounted platforms are used to work on the electrical infrastructure network in Australia, please?
Yeah, thanks for the introduction, Mike. It's a pleasure to be involved in the webinar. Truck-mounted MEWPs have been used in the power line construction and maintenance industry in Australia since the late 1980s. With the introduction of the computerised units with high-capacity cages, this increased substantially in 2005. For Australia, a vehicle that is designed for off-road use is a must, and most of them are mounted on either 6x6 or 8x8 chassis. The requirement to travel along narrow, unsealed access tracks present additional challenges with very high centre of gravity vehicles. Side slopes have unfortunately proven too much at times, and incidents have occurred resulting in major damage to the equipment, but thankfully minimal damage to the drivers. Approximately 95% of the work conducted in Australia is undertaken with the power line de-energised. The other 5% involves large insulated units capable of working on the lines that are still energised with voltages between 110,000 volts and 500,000 volts. These insulated units are not like the ones used by the local power distribution companies. They have a steel boom and only an insulated fly boom or cage boom. For general construction and maintenance, the units are used under isolation permits or construction permits. With the power isolated, there is still very stringent processes and procedures that must be followed. Work plans need to be prepared and approved. Correct equipment for the task is arranged. Work areas identified, suitable area to set up the MEWP, ground conditions, terrain, overhead obstacles. You can sort of see in the image behind me in a rough terrain area. On-site pre-start meetings, also called JSAs or job step analysis or task risk assessments, are completed. The MEWP is earthed to the structure. This will be via a very heavy-duty earth cable that is tested regularly and in a current test and tag. The earth lead is first attached to the structure earth point and then to the MEWP. Only after the unit is earthed is it permitted to be set up and raised from the transport position. A smaller hand earth will then be secured to a metallic part of the cage and bonded to the line once they are working at the height. This is done via a hot stick and insulated gloves so that the operator does not subject themselves to any electrical hazards. When the job is finished, the earth remains until the truck has been packed up. Then the earth is removed from the MEWP first and then from the structure. They also utilise OEM approved attachments. Many of them will use manual handling equipment like winches so that they can lift components like insulators and rollers and structures up onto the cross arms. This saves time and space, as in many locations you may only be able to set up one piece of equipment. Loading tools and equipment into the cage and the unit is now ready for work. During power line construction, before there are any wires on the cross arms, helicopters are often used to run the draw wire through many structures. This will sometimes require the MEWP to be operated underneath the helicopter as it hovers overhead. Additional procedures are always in place for that, like communicating with the pilot, etc.
Excellent. Thank you, Peter. Question number 2. So what does the future of power line construction look like in Australia in the coming years?
Future power line construction in Australia is very stable at the moment, with over 2,000 kilometres of new lines being constructed and more than 10,000 kilometres of lines that need to be upgraded. The demand for the large truck-mounted EWPs will only increase. There's approximately 50 units in Australia that can achieve a height over 60 metres. With the large projects requiring at least 10 of these on each project, the hire pool drains very, very quickly. Principal contractors need to plan well in advance to book equipment early, sometimes more than 6 months ahead of time. Equipment owners also need to keep their fleets 100% ready for work and have the ability to conduct the service maintenance outside of normal hours is also very critical. The projects span the continent and in many cases require the work teams to be accommodated in camps for lengthy periods of time. Working away for months and working 13-day fortnights requires a major focus on fatigue management by the hire companies and the principal contractors. There's constant monitoring of operators is vital to ensure everyone goes home safely.
Excellent. Final question, Peter. We were both involved in the investigation into a fatality that occurred in Australia some years ago in an induction incident. Please could you explain to our viewers what induction is and how the fatality could have been prevented?
Thanks, Mike. Yeah, this type of investigation is never pleasant. The situation occurred while a new power line was being constructed. The new line was built adjacent to an existing 132,000 volt line. This existing line remained energized during the project. Due to the significant electromagnetic fields present around energized high voltage lines, voltages may be induced onto the adjacent de-energized or non-commissioned line. These voltages can be large enough to deliver potentially fatal electric shocks. During construction, in this instance, the principal contractor will utilize what they call construction earths. These are cables placed on the wires and back to the structures every set number of structures. That distance, in this instance, that distance was too great, and when the operator in the cage removed the earths from the line they were working on, he created a path to ground for the power through his body. The second occupant in the cage had to try to break contact between the deceased and the line to the top to stop the electrocution. As the truck was earthed, as mentioned earlier, the electrical contact and current did not have any detrimental effects on the electronics of the MEWP. Once the contact was broken, the operator on the ground was then able to use the radio remote control to bring the cage down to ground safely. The investigation showed that the construction earths needed to be positioned at closer intervals. The amount of induction that was occurring was greater than they anticipated. The investigation also showed that the deceased person had not followed the correct procedures and using insulated gloves and the hot stick to remove the earths from the line. There's several resources available that can explain this scenario that have been developed in Australia since this incident and other fatalities.
Excellent. Thank you, Peter. That's it. That's our 3 questions. I'd like to thank you so much for your time. It really has been greatly appreciated. And I'd like to thank you for your input as well into the development of that guidance note, the safe use of MEWPs in the vicinity of power lines.
It's been my pleasure. Been my pleasure. Thank you.
Again, thanks to Mike and thanks to Peter there. But for both of those guys and the whole of the working group, a really big appreciation as to the amount of time they put in. You know, writing guidance it does take a huge amount of time, and the guidance itself we're trying to make the guidance global, so that's why we don't always specify specific distances, etc. But certainly, the guys earn their dollars when they're installing those power lines around the infrastructures in the countries. Okay, so now I'm going to hand over to Jim Walden of Skyjack. Jim, the floor is yours.
Thanks, Brian. Let me just share my screen. Okay, Brian, let me know that you can see my screen.
Not yet, Jim.
Can you see it now?
Going through now. Yeah, got it now. Thank you.
Well, thank you for letting me present at today's session. We've heard some really powerful stuff from Cookie and some informative information from Peter, which I think might be able to build on. I've been asked to present a little bit about the machinery regulation, so it's fairly European in its focus, and I've been given 5 minutes to walk through what is effectively a couple of years of debate. But in essence, the machinery directive that's been in place in Europe for many years is being replaced by machinery regulation, which has been excitingly called the Regulation 2023-1230. And it was published this year in June, entered into force in July, and it becomes fully applicable in January 2027. So the industry has until January 2027 to understand the full implications of the machinery regulation. As the manufacturers technical committee chairman, I have briefings from the European Materials Handling Federation, who provide some information on the changes to these regulations and associated standards, and some of the challenges that they propose. So The directive is being replaced by regulation, and in principle, that's a good thing from a European perspective. So we've moved away from being a directive, which in its own right is not directly applicable to member states. They're interpreted differently, and they need to be transposed into national law before they become effective. Europe has now published a regulation, which is great. So now every member state in Europe is signing up to the regulation from the get-go. So it's applicable directly across all of the European Union. The implementation of that regulation will now generate some change to the standards and force development of standards to understand how we meet the new requirements within the regulation. But before this can be done, we need to understand the impact of those changes. And there's one particular change in the machinery regulation that, that is meaningful to today's presentation. And that's the introduction of a new, what's called an essential health and safety requirement within Section 3, which is a number of requirements that machinery, and specifically moving machinery, must comply with. And some of the words in the requirement are ambiguous, and I'm going to share the requirement with you, and I'll read it through verbatim, but then just highlight some of the areas where there is, at the moment, some confusion within the industry around how to interpret this requirement. So the risk, the requirement itself is, depending on its height, the mobile machinery or related product shall, where relevant, be designed, constructed and equipped so as to prevent the risk of contact with an energized overhead power line, or the risk of creating an electric arc between any part of the machinery or an operator driving the machinery and energized overhead power line. The second statement is, when the risk to persons operating machinery incurred by contact with an energized overhead power line cannot be fully avoided, mobile machinery or related products shall be designed, constructed and equipped so as to prevent any electrical hazards. It's a bit of a mouthful. I'm not expecting everybody to read that and digest it all. There's been an awful lot of work looking into this and how it's written. And there's some areas of this particular clause and requirement that are drive a bit of ambiguity. The introduction of a requirement, I think, is applauded. Having a requirement within the regulation to understand the context of the risk of overhead power lines is really important, and the electrical hazard that introduces. But there are certain words that can create a bit of confusion in how to implement this requirement. As written today, the only machines on the market that can be placed on the market would be fully insulated machines. There's very little wiggle room for anything other than fully insulated machines, which at the moment constitutes a very small proportion of the in-service fleet. And touching on Peter's presentation, which I thought was very interesting, that the 95% of work on all overhead power lines is on de-energized. It's only 5% of work on overhead power lines that's using energized lines. But this requirement will apply to all machinery that's placed on the market into Europe. So I've highlighted some of the wording in red, which I think is driving some of that confusion. Firstly, and Brian's already mentioned this, and it's been reinforced by Cookie's presentation, the requirement is for overhead power lines. But what that doesn't do is understand the risk associated with hazards of underground power lines. And quite often the implementation of machinery that works at the height, the power lines may be adjacent or below the machinery once it's been installed. So overhead power lines in its context isn't an accurate definition to hang the requirement on. And then some wording which is surprising to find in a legal document, but depending on its height, is a very ambiguous open statement. And it's very hard to quantify that when, depending on the voltages, the lines, the pylon designs, they're different across the European community. So the heights and the safe working distances can vary across the European community. This is now open to all technical committees to try and interpret. If you can't mitigate the risk, then the final statement is looking at trying to, if you can't fully avoid the risk, then you must prevent the hazard. And by virtue of there being a hazard, there is a risk. And working near powered power lines, there is always a residual risk. There is always, it's always a risky environment if you are working near power lines. And I think, again, leaning on Cookie's presentation, which was really insightful for me, knowledge is the best defense. Knowing where the hazards are and knowing how to mitigate them through use and potential design improvements is really where this takes us. But with my last minute, I just wanted to say what does this mean to us? At the moment, the industry is challenging this requirement within the machinery directive, machinery regulation, as it's written. We applaud its introduction, but not necessarily the wording. It's very hard to comply with that. And at the moment, the position across a number of industries represented by FEM is that it's you cannot comply with it as written today. However, the European Committee has accepted that we can continue dialogue on the requirement and help define the guidance document. So the regulation will have a guidance document that goes with it that's a lot bigger, hundreds of pages, and each clause is written into an explanation of what it really means. And we've been invited to that, and we are open, and that is currently open as a dialogue. And the next meeting on the Commission on Machinery Expert Group feedback on this topic is on the 9th of November, which the FEM has represented our industry into. So hopefully some of those red underlined items can be clarified in the guidance to say what it really means. So really the objective of the requirement to try and help mitigate the risk is the right one, rather than being an unrealistic clause that can't be met with designer machinery. You can't design out power in an overhead power line through the mute, so the hazard will always be present unless you turn it off. So reflecting on the question that I was asked for this presentation, which was how will the regulation affect manufacturers, rental companies and hirers or users of machines? I think at a very top level, manufacturers will use the regulation as a catalyst to explore technologies and grow the insulated market. And you'll probably start to see some more third-party systems, such as the one that Cookie showed, like Go Up Safely. There are others in the marketplace as well. But those systems, those third-party systems, will probably gain more prevalence and more traction as the regulation changes and introduces, and the hazards associated with job sites justify their application. For rental companies, I think this introduction of the regulation doesn't remove the need for diligence, for site surveys, for the correct machine selection at the beginning of a task, and the correct option selection and the correct maintenance of a machine. An insulated machine only remains insulated if it's maintained correctly. So it's really important that those things that are currently established are maintained. And then for users and hirers, the introduction of this regulation does not, and I don't think it will ever remove the need for the appropriate risk assessments, the right level of training on sites, the right operator training, and the vigilance that Cookie was highlighting. You know, that human factors perspective where the hazard becomes masked in your mind. You know, how do users protect against that, and how do they inform their staff to protect against that hazard? So wrapping up very quickly, for the industry, I think it's a recognition, this change in the addition of the requirement is recognition of hazards working near power lines, and it'll have a positive impact on the IPAF statistics if the risk is handled responsibly, and the guidance that we can create around the requirement in the regulation support some of the activities that we know users and hirers are already trying to do, and some of the things that Cookie highlighted and the things that Peter highlighted in his presentation. I think it can only help and augment it if it's interpreted correctly. So without further ado, I'll pass back to you, Brian, for the Q&A session. Hopefully I haven't gone too much over my time.
Thank you, Jim. No, you were good on time. Can you just stop sharing for 1 second, mate?
Yeah.
And can you still on share, I think?
Yeah, there we go.
There you go, mate. Okay, thank you. Okay, so we have got a number of questions in. I think you've been quite kind to us, because normally we get quite, I think 45 was the most ever questions, which was quite challenging. But we've got an anonymous attendee has asked about, is this a safety device? Now, I'm not sure what that's referring to. I presume it will be referring to the device that Cookie alluded to, the Go Up Safely. In respect to that, Jim, have you any thoughts on that when we're looking at that?
Yeah, it should be a safety device would be my response to that. I don't know the system closely. I think it's called Go Up Safely. If any third-party manufacturer of a system is putting a component or a machine or a system onto the market, they need to make sure it meets all the right requirements. And if this interrupts controls a MEWP, then you would need to make sure that it meets the same safety conditions that that the control system would conform to. So I think I saw a question on, does it meet EN8, the 13849, I think I
think it was, yeah.
I think, which is about safety related parts of control system. So you would argue if the human factors of the person on the basket is thinking this system is going to protect them from power lines and they keep going until the system stops them, then it should be considered a safety function, and it would be a safety system that would need to meet that requirement, would be my perspective on that system. I think as the MEWP type standards start to get looked at in light of the new machinery regulation, we already ask for safety parts of the system to conform with that standard. The question is, how would we describe a system that introduces some form of proximity mitigation if that's the way the MEWP standard evolves?
Yeah, no, I agree. And I think at this point, it's probably worth noting really that in respect of any sort of safety device or safety product in that sense, I mean, IPAF, we'll never promote or endorse any products. I think it's not the right thing to do. And what we do say in our guidance is it should be noted that there is no one particular device or system that will prevent electrocution or electric shock in all known circumstances. So I think, like you've just alluded to there, Jim, you've got to do your due diligence. You've got to look at your systems, but we were given a pair of eyes, and we need to plan properly. We need to risk assess. We need to make sure that the job is and the equipment is the right type of machine for the job that we've selected. Okay, I've got a question from Rob Cavallari. Can you share or recommend some good sources to obtain stake hole weight video training material? Rob, certainly that's one I can pick up with you afterwards. I think from Cookie does allude, I think he's got his own very, very well used website, albeit he doesn't just do things in Australia. He is a global ambassador for this type of thing. So, and I do know, of course, he's been in other countries. So certainly one to get in touch with. Peter Fowley. Peter, you've asked, what information and guidance do you have on EMFs? So EMFs would be electric magnetic fields when working near power lines. Peter, I would advise you really that you go and look at the guidance document. All our guidance documents, certainly since I've joined IPAF, they are a live document, and we will take advice and information if somebody has any thoughts, or maybe even if we've perhaps not gone into as depth that we needed. Jim, I don't know if you've got, I know we've discussed EMFs at the manufacturers technical committee. Any views on that particular point?
No, I think I'm kind of, if I interpret that as kind of RF zones around potentially transmitters, I think that's what it's sort of alluding to, as well as around the power lines and the potential interruption onto systems. And from a machinery perspective, there are standards that we comply with for EMC susceptibility and transmissibility. So that susceptibility piece is probably what you're leaning to there. I know when we looked at it at an IPAF level to generate some guidance, it was quite difficult to get through perhaps some of the information that's contradictory with other information, and it's all freely available, but it's a bit ambiguous. And with the introduction of 5G into the marketplace as well, we found it quite hard really to get something quantifiable to say, well, what is the risk and how do you mitigate it? Other dimensions and distances that you need to be careful of in terms of the human factors aspect of overheating and potential impact on the human body, and then disturbance on the machines. The machines is covered under an EMC regulation, but the impact on the human aspect is a bit more ambiguous when you could read 10 doctors' reports and 5 substantiate the risk, and then 5 can debunk it. So IPAF we're not medical, so we couldn't really make a determination of which side of that to lean on. So I don't think we resulted in a meaningful document that covered that side of it, Brian, from my recollection.
Yeah, agreed. Yeah. We've got a question from Yao. Any permit to work apply to work in high voltage power lines nearby? I would certainly advise wholeheartedly that you should have a full permit to work system when you're in place and working near power lines, and that permit to work would include your risk assessments, your safe methods of work, your training, your briefing, etc. So for sure, I think that's one to consider if you haven't done also already. Jim, you mentioned earlier about the rewording and clarification of the regulation. Jason has asked the question, how can one be considered for input? So I think Jason's alluding to, you know, could he be involved in something like that? I'm not sure if they allow any, you know, people to join now, or is it too far down the line? Your view on that?
I mean, I think we need to keep the current communication lines formalised as they are through the FEM. You know, members of the manufacturers technical committee, so IPAF members have the opportunity to highlight feedback, input, concerns through the MTC into FEM, and they can be represented through the formal channels into that committee session on the 9th. So if there are any concerns with the wording, and I presume this presentation or the video will be released after the event, so people could see the wording of the clause, and you can download it for free off the European Commission website, so you can get access to the regulation now already. So if you do have any comments or observations as an IPAF member, then by all means share it with IPAF, but we would form that through the formal channels of the MTC into FEM.
Okay, great. Thank you for that, Jim. All right, so I'm just conscious of time. This webinar was scheduled for 1 hour. We did have a slight delay just due to a technical issue, but thankfully we got past that. Hopefully I'm still sharing my screen. I just really want to sort of highlight on accident reporting. You know, today's webinar is focused specifically on electrocutions and electric shocks in the powered access, but our accident data that we receive doesn't really stop there. We look at all elements of working in and around powered access, so mast climbers and also hoists. And as we continue to reach out to you and welcome reports from countries all around the globe, it's really important. So, you know, if you do witness a powered access incident or a near miss, you know, please do report them. You can also now use the IPAF EPAL app to report, and that IPAF EPAL app report will come through anonymously, and you know, your name will never be mentioned. But equally, anything that you report, so if, for example, I've got Jim on the call today, if you typed in the word skyjack on that report, we will remove that word skyjack so that it's just anonymized completely. And also it's also confidential, so that kind of information will never be you know, displayed or reported on. For those who are registered users of the accident reporting portal, you also have access to a members dashboard portal, which is configurable in certain elements. So you can see here particularly things like configuration, classification, location, the types of injury and the types of body part. This certainly allows users who have registered for the portal to use that to benchmark themselves against their industry. And I've kind of showed on here an example of IPAF North American reports versus all the reports that come into it. So you can see there, and hopefully it's something useful. And these are able to be, you know, PDFs, so you can produce them and report. If you're trying to make a case for, look, we need to do more training around, you know, overturns, whether it's false on the platform, whether it's entrapment or something like that. So these are really, really useful things to sort of help and support you. And lastly, really, finally, you know, this is on our webpage now. It's the Global Safety Report for 2022. I did allude to it earlier in my presentation. You know, we can't cover everything in a webinar for today, but this is going to give you some more insight into sector-wide information. So the link's there at the bottom of this. As Jim mentioned, this presentation will be available on YouTube in the next couple of days. But, you know, hopefully you found today's useful. I would really like to thank our speakers today. So Glen Cookie, Peter Wellspring and Jim Waldron, and of course, Mike Ashton. I'd also like to thank our exclusive sponsors today, Palazzani, for their support for this webinar. And lastly, thank you all for taking the time, registering and attending today and watching, or even if you watch the webinar later on the IPAF YouTube channel. But for sure, we'll continue to do these webinars as we see interest. You know, we've had over 450 people register today for the webinar, and there's still a very good number involved in the webinar today. So thank you very much, and take care, everybody. And please use the guidance that we've provided. Thank you.